Show that sine z is equal to e to the iz minus e to the negative iz over 2I. We're going to do this using Taylor's series. And so we're going to start with sine z. That's just z minus z cubed over 3 factorial plus z to the 5th over 5 factorial minus z to the 7th over 7 factorial, etc. And then e to the z is just 1 plus z squared over 2 factorial plus z cubed over 3 factorial and then plus z to the 4th over 4 factorial, etc. So now we're going to replace it with e to the iz. So for every z, just replace it with iz. And then we're going to simplify. So I squared is just negative 1. So this is negative z squared over 2 factorial. And then I cubed is negative I, and then z cubed over 3 factorial. I to the 4th is 1, so that's going to be z to the 4th over 4 factorial, etc. So this is e to the iz. And then e to the negative iz. We're just going to replace z up here with negative iz. And then we're going to simplify. So we have 1 minus iz over, on the bottom we have 2 factorial. On the top we have negative I times negative I, that's I squared, which is negative 1. Negative 1, so we'll have a negative outside, and then a z squared. Okay, so I made this a little too big. Let me just rewrite this. So it's negative z squared over 2 factorial. Negative I cubed, that's going to be negative 1 times I cubed, basically, which is negative 1 times negative I, which is positive I, and then z cubed over 3 factorial. Negative I to the 4th is 1, so that's going to be plus z to the 4th over 4 factorial, etc. So then we're going to subtract e to the iz with e to the negative iz. So when we subtract these, we have e to the iz minus e to the negative iz. The ones are going to cancel. Iz minus negative iz is 2iz. Negative z squared over 2 factorial minus negative z squared over 2 factorial, that cancels. And the negative iz cubed over 3 factorial minus iz cubed over 3 factorial will give us 2 of those. So 2iz cubed over 3 factorial. And then the z to the 4th over 4 factorials will cancel. And so now this one, I can divide both, or I can factor out a 2i and have z minus z cubed over 3 factorial. And I guess I should go one more. Let's go one more of these actually, just to see the pattern. Let's say z to the 5th over 4 factorial, or 5 factorial. And this will be iz to the 5th over 5 factorial. So this will be I to the 5th is just I, z to the 5th over 5 factorial. And then negative iz to the 5th over 5 factorial. see, so that's going to be negative I z to the fifth over 5 factorial. So then when we subtract the z to the fifth, I z to the fifth over 5 factorial, that's going to be 2 of those guys. And so when we factor out a 2i, it's going to be z to the fifth over 5 factorial. And recall that this over here in parentheses was sine z. So we can replace that. We have e to the iz minus e to negative iz equals 2i times sine z. And then dividing both sides by 2i, we get that sine z is equal to e to the iz minus e to negative iz over 2i.